For this session, we're going to be talking about climate adaptation, tech in a tube, enabling wind seismic resistant homes. As we start to see the impacts of climate change occurring more and more, and just wanting to make our buildings more resilient to weather, this type of technology and this conversation is going to be more important than ever. So we're very excited to be having that conversation and continuing it today. Now, before we get started, we always want to do a membership, GreenHome Institute membership spotlight. Our member, Sean Ninehouse, recently completed his certified GreenHome professional credential by taking our online on-demand course. Sean also recently won a copy of the new 7th edition of John Krieger's Residential Energy when he last attended our webinar around the book. So in both cases, these efforts will help Sean as a construction project manager at the GHI member Kent County Habitat for Humanity affiliate. Sean will be assisting in the construction of all LEED certified housing to continue to reduce energy bills for families in need, and a mission to improve housing performance, which brings in further equity to families in need of owning higher performance home. So we commend our member Sean for his eagerness and willingness to learn, and congratulate him on this achievement. You know, this is who GreenHome Institute members are. This is what GreenHome Institute members do. And so can you head over to our website and learn more. Also, before we get started, a huge thanks to our platinum sponsor, Mitsubishi Heating and Air Conditioning. They won the award for most reliable central air conditioning system, and they're not even an air conditioning system. What they are is a air source heat pump technology. I have one, and they have their all new all climate technology, which allows their hyperheat systems to work down in coldest of cold temperatures. They have ducted systems that can swap out gas furnaces, ductless systems like mini splits, ducted mini splits, and variable refrigerant heating systems, which have built-in energy recovery ventilator systems. Now, like I said, if you're not ready to, you and your clients are not ready to go all electric, they have outdoor condensers that can be paired in with indoor condensers, such as their IntelliHeat product, which allows kind of the best of both worlds. When it gets super cold out, still relying on that gas furnace. They have it easily figured out how to pair indoor with outdoor to meet Inflation Reduction Act, tax credits, and homes rebates that are coming out as well. So make sure to head over to MitsubishiComfort.com to learn more. All right, again, welcome to Climate Adaptation, Tech in a Tube, enabling wind and seismic resistant homes. This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. I am the education manager here, Brett Little. This course is approved for multiple continuing education units, including 3 pillars of green, place, health, and or place, energy, and materials within our certified GreenHome professional designation, including AIA, health, welfare, and safety, may make it applicable to your state-based design or contractor license. Check out the Passive House, certified Passive House code at the end to get your CEUs when you complete the course. So as I said, I'm really excited to introduce our guests here today. And hand it over to them. Kristin, Corra, and Phil, as well as the founder and owner of Climate Incorporated. So I'll let them introduce themselves and their company, and please, go ahead and take it away.
Thanks, Brett. So I am Kristin Corra. I am helping out with business development for this exciting novel adhesive, and next to me is our founder and senior technical advisor, Phil Giorgio. I'm going to talk about.
How do you do? Yes, I've been developing adhesives for 45 years, and this company is the ultimate solution to construction problems that we've been experiencing for a number of years. So we hope you enjoy this presentation. Thank you.
Now we're going to share a video about some of our testing and our exciting results. Have a look.
While there are many efforts throughout the world dedicated to taming climate change, there is an additional action that can be undertaken, one not aimed at managing the weather itself. Instead, this action is aimed at constructing buildings that can survive extreme weather. It's simple, inexpensive, and perhaps best of all, immediate. Better buildings, more survivable buildings, can be constructed with one simple step: the use of a resilient, shock-absorbing adhesive applied to certain areas in wood frame construction. That is what researchers at Western Michigan University's Bronco Construction Research Center in Kalamazoo, Michigan set out to prove. And test results show that the use of specially formulated adhesive in the right places can bring remarkable results. Lead investigator Dr. Bilal Al-Hawamdeh and his team are running a monotonic test on an 8x8 wall. This is one in a series of tests that were conducted to determine the benefits of using an adhesive in light frame wall construction. Previous tests involved walls constructed with 2x4 studs and 3/8 inch plywood sheathing in 3 different configurations: nails only, nails combined with commercially available polyurethane adhesive, and nails with a specially formulated polyether adhesive called Climate. These were tested using a dynamic testing method. As the graph shows, results of dynamic testing on these 3 wall specimens were striking. It required more than 9,000 pounds of force to break the wall assembled with Climate adhesive. The nailed assembly failed at 4,000 pounds. But the story is about more than strength. The ability to absorb energy, to displace it, is critical to a wall surviving the dynamic forces of a hurricane or seismic event. The 3 2x4 walls were also measured for their displacement properties. These hysteresis curves show the lag between the force applied and the wall's response to it. The greater the lag, the better the system's ability to displace force. For the nails-only wall, the loops remain relatively close to the horizontal axis. This is due to nail slippage as force is applied, known as pinching. The specimen consisting of nails and polyurethane adhesive, labeled Adhesive A, shows better displacement than the nails-only wall, and while it is strong, it is also somewhat rigid and limited in its ability to dissipate force, resulting in relatively brittle failure compared to Adhesive B. The large area within the Adhesive B Climate hysteresis curve, with its many high-volume loops, shows an extraordinary energy-absorbing capacity. The test being conducted here in accordance with ASTM E2126 involves a wall constructed with nails and Climate adhesive. The wall specimen, composed of 2-inch by 6-inch studs on 24-inch centers, is a configuration that allows for an increased insulation cavity, thus providing superior R factor. It is also a more efficient use of wood because of the need for fewer studs. This specimen will undergo dynamic forces, or cyclic loading, intended to represent the impact of a high wind event. Previous testing on an identical wall assembled with nails survived only 4,200 pounds, or 4.2 kips.
The purpose of my research was to investigate the effectiveness of the elastomer adhesive applications into light frame shear wall wood construction. So the purpose was to evaluate the shear strength and the shear stiffness and the ductility of different components when the adhesive are applied into their connections. So the overall goal was to ensure a continuous load path into those structures from the highest points, or from the points where the loads are subjected, all the way down to the foundation level and into the ground.
The testing machine consists of a top-mounted 20,000-pound double-acting hydraulic actuator, a steel loading beam at the top, which includes a roller system to contain lateral wall movement, a steel base channel, and bolts attached to the shear wall sill plate. Displacement measurements are taken at the top and bottom plates and end studs. Laser sensors are used to record the uplift displacement at the end studs. A special computer program captures the wall specimen's response to stress loads and movement. This is the hysteresis graph, which shows displacement in dynamic push-pull forces. The characteristic bow tie image begins to take shape.
How the nails or how the mechanical fasteners work Nails are localized spots that can provide some level of friction between the two members. If you have, say, wind load subjected to the top of the roof, the way how it works, the loads will be, by science, needs to move and transfer from that components to the adjacent components. And if you have a gap, if you have a weak points into that path, transfer path, if you have a continuous load path, the loads can move and transfer all the way through the components down to the foundation. That's the goal.
As the load approaches 14,000 pounds, the climate-bonded wall begins to fail with a sharp crack. Most striking is that failure in the specimen occurs not along any of the bond lines. Instead, as the load path travels uniformly down the wall, the adhesive continues to displace energy until it reaches the foundation. The main wall assembly is completely intact. Failure is concentrated totally within the bottom sill plate with a longitudinal 2 by 6 inch split. This is testament to climate's ability to absorb and dissipate energy away from construction interfaces, functioning like a shock absorber throughout the wall and delivering energy to the foundation.
Climate adhesive, as it has inherent high elongation property and better movements that can reach to 1,000% of elongation. So imagine if we have, as an example, a bond line that has a thickness of a 1/4 inch. This 1/4 inch can be stretched up to 10 times. That will provide that movements that we are really looking at, and that also can increase dramatically the seismic energy dissipation, where we can evaluate the behavior of the structure by how much the structure or the connections or the components can dissipate energy.
WMU testing proves that the use of special adhesive can dramatically increase the structural integrity of light frame wall construction. The adhesive is also applicable to roof rafter construction such as birdmouth joints, which are critical to keeping roof and wall elements firmly attached under violent wind conditions. Bronco Labs continues to explore the benefits of constructing buildings with the use of flexible, elastomeric adhesive, which can function as an energy absorber, allowing buildings to survive high wind and seismic events. Of course, we must continue to develop practical issues for managing the climate, but we must also learn to construct more survivable buildings.
So I hope you enjoyed the video and your curiosity is piqued. We are the firm believers, because we've seen the data and done the testing over the last 6 years, that innovative chemistry can help make the visual in front of you a thing of the past. The challenge that we face as ever increasingly more frequent and violent high wind events due to climate change. We know this has been in a number of UN reports. It's very well broadly understood, unfortunately, that now 100-year events become every other year events where communities, FEMA, and the insurance companies struggle to recover in between. Passive houses require durable, high-performance, whole building adhesive solutions, as well as tight envelope integrity for energy and efficiency. So not only are you covering the sustainability issue with that energy efficiency, but also we aim to help add another dimension to that with climate change adaptation technology to deliver structural fortification, protecting lives and the investment and your home. Sustainable structures are resilient structures, where it's time to make sure that sustainability of all stripes are included in code specifications and design. This is a map of the United States of most vulnerable areas to high wind, noting the typical coastal areas, but also that mid-continental wind area is, people don't often think of that necessarily, but it's also extremely vulnerable, and we aim to make sure that we deploy to all of those vulnerable areas. Another area that the adhesive is a solution for is seismic events. Those are not necessarily related to anthropogenic emissions, but nonetheless, they are increasing in property damage, 14.7 billion annually in the U.S., which is a 140% increase over estimates since 2017. And we've seen internationally quite a bit, even in the last year alone, significant loss of property and life in Afghanistan, Turkey, Morocco, Japan, Taiwan, and just recently in this month in New York City, which is obviously incredibly densely populated and not usually, not prepared for seismic events. There's also not related to seismic, but there's also rising sea levels, which will necessitate new construction, for which this product will definitely help with fortification in the future. So if you recall the former map of the high winds, some places are also on the hot spots for seismic risk zones in this country. This is not just obviously a U.S. phenomenon. The United Nations Framework Convention on Climate Change, UNFCCC, just created in its COP27 a loss and damage fund. That's really critical to helping less developed and really vulnerable island nation states have their voices heard and help those who are most affected by climate change but had least to do with it, try to get some ability to adapt and to have ability to overcome some of the significant setbacks that climate change is making them endure. So novel construction adhesives are an accessible climate adaptation solution that we're really excited to help deploy, both via federal agencies domestically, as well as part of potentially our nationally determined contributions to the United Nations for global partners that are definitely in need, in the Caribbean and Asia, lots of areas that really definitely need fortification of their structures. Phil would like now to talk a little bit about the evolution of how we came to this solution.
The development of adhesives, particularly one we have now, is somewhat biographical because I started working on this in 1970 when I was working for the American Plywood Association, with the American Plywood Association, in developing the first composite floor system based on adhesive bonded plywood floor joist assemblies. To advance this system, they engaged the help of 4 construction adhesive manufacturers to develop a performance test for plywood floors. I was involved in the test protocol as a product development engineer working for U.S. Plywood's Weldwood division, one of the collaborating firms. The collaboration resulted in a test protocol, AFG01, which demonstrated that a single ply flooring system using adhesives increases the structural integrity of such assemblies at least 200% and reduces the span tables of floor joists. The results yield a substantial savings in lumber, as well as a reduction in the quantity of nails required on a project. AFG01 is still in use today. Engineers at APA tried to expand the use of adhesives to walls and rafters with what they called a Mod 24 system, which was studs 24 inches on center and bonded and nailed, similar to what the subfloor system was. This concept was not well received by spec writers because they could count nails, but a bonded glue line could not be verified. APA's modified Mod 24 program was never implemented. My product development career moved forward from Weldwood to St. Clair Weber Automotive to Context Sonneborn and ultimately to Chemlink, the company that I founded in 1990. The evolution of construction adhesives advanced substantially since 1970. Solvent-based adhesives, which were often flammable, were replaced by acrylic latex polymer-based products. These then were replaced by moisture-curing urethane adhesives. I pioneered the development of silo-terminated polyether sealants and for use in roofing, waterproofing, and structural bonding. Through all these years, I never lost sight of the potential for bonding panel-on-frame assemblies through the entire structure of residential wood frame construction. In the last 20 years, the frequency and violence of weather has increased the annual loss of lives and property in the United States. The assumption that nails alone will save lives failed time after time. Doubling and tripling of nailing schedules has proved to be of little value in catastrophic wind and seismic events. Hurricane straps and hold-down devices have only localized value in wind and seismic events. The cost of such hardware and associated labor are significant while offering little performance value. A continuous bond between all lumber and plywood interfaces, plus a bonded bird mouth assembly with the wall and rafter joints, offer the ultimate structural protection. And the use of adhesives does not violate code in any way. Adhesives only enhance the performance of the entire structure. Testing showed that a bird mouth assembly with toenails alone resisted 250 pounds of tensile force. With a hurricane strap, the same assembly yielded 350 pounds. The bird mouth specimen bonded with a specially formulated adhesive and nails reached 1,200 pounds before failure. Fatigue testing also showed that cyclic loading survived much longer with highly elastic properties of this new adhesive. In mechanically attached assemblies, nails and hurricane straps fail fairly early in cyclic testing. When nails pull out, they never go back in. But a flexible adhesive absorbs energy and returns to its original position. New polymer technology promises both strength and adhesion with highly elastic properties. Adhesives applied over the exterior lumber surfaces spreads the load path laterally across the entire structure and finally dissipates at the sill plates or the foundation. In pursuit of this architectural concept, I took 50 years of industrial experience and invested it in formulating an adhesive which can be used to build fully laminated structures that increase the survivability of our homes in adverse wind conditions and seismic events. When buildings survive, people survive. Thank you.
Awesome. So the opportunity that this adhesive, a new class, provides is that now such built environment damage is wholly or partially avoidable. The formula that this chemical sweet spot, so to speak, that Phil discovered and as we're now producing at scale, it's most suitable for light frame wood new construction, but also concrete. There's a self-leveling viscosity that is appropriate for horizontal applications. But these high performance adhesives enable cost savings in lumber in both the amount and type, therefore also labor, and lessens obviously the mechanical fasteners, all that with increased performance. We also believe that built environment consumers should start to demand a do no harm ethos of construction supply chain. Ours is a non-toxic formula, so it's produced without solvents and therefore no HOV off-gassing. That's also part of, obviously, our vision of sustainability. It's really time for the world to understand that novel construction adhesives can offer exponentially stronger bonds than mechanical fasteners and much more dynamic. So when you have a load path that's extraordinary, that's also cyclic, matched with elasticity, these two factors save lives and structures, and that's the whole idea. The solution, so we want to get into a little bit of the data that you saw in the video, and they're also in some scholarly journals that are available on our website. But the takeaways that we're really excited to deploy globally are that its load capacity is increased 250 to 300% versus nails alone. And that's all via a uniform code schedule. And And that's all also without the undue embrittlement that some of the 80s and 90s evolution of the urethanes that Phil mentioned in his talk. The really novel, exciting piece, in addition to that, is the 950% joint elongation, where it's able to return to its original joint position, absorbing that, and therefore demonstrating that level of ductility. It doesn't exist on the market today, and therefore is increasing the structural resilience, dissipating that load path from rafter to shear well down to the foundation until the sill plate, where you saw it break laterally in the video. It also really importantly outperforms mechanical hurricane straps by 2.5 times. In strength and durability, you also get therefore those cost reductions of both the materials as well as labor time of putting in all the various configuration of hurricane straps versus applying via a caulking gun a 1/4-inch bead of adhesive. It's extremely durable, it's non-toxic, it's moisture curing down to freezing point. And so it's also accordingly getting different certifications, and we're in the process of getting several more of those. But that's including FEMA's P695 for seismic modeling, California Prop 65 regarding toxicity and anti-carcinogenic, as well as the APA AFG01 that Phil talked about it's already being within code and overperforming for the flooring to subfloor adhesives. So the pathway we feel, which is imperative to get deployed as quickly as possible before the next natural disaster unnecessarily causes structural and hopefully not, but definitely we've seen over and over fatalities, is this is a climate change adaptation solution that is really accessible because it's very affordable compared to the investment that people put into, relocating from rising sea levels. You're going to determine, what your flood zones are and what different zones are where you're not able to be insured anymore because it's just too vulnerable. At least those that are being, replaced are then as durable, as resilient, as fortified as possible via this chemical solution. So we have tested with the potential to withstand loss and damage from Category 4 hurricanes, F3 tornado levels, and 5 Richter scale earthquakes. And the solution is ready to go. We are able to deploy at scale, and it's made in America right now. So we are extremely excited to partner with you and figure out whatever your engineering challenges may be, and explore the power of chemistry over catastrophe to help ensure that survivable buildings are the new normal in increasingly vulnerable regions. And both of our emails are on the screen, so we look forward to being in touch with you. We'll now take some questions.
So one of the first questions that came up was thinking about these liquid applied air barriers. People notice them on high performance passive house projects. How similar, if at all, are that with this kind of technology?
I'll try to answer that, because our adhesives are just that. They hold different components of the building together, but they don't serve to be a barrier against infiltration of moisture, air, and generally holding out weather. It's not that kind of product.
So the next question that came up was, what is the durability and longevity of this technology? And there's a specific question in that they were asking, what is the derating of the bond over 20, 50, or say 100 years in service?
I'll try to answer that briefly. The test that you have for AFG01 for subflooring has a durability section in it. It involves high pressure oxygen at high temperature and for 30 days. And it's predictive of more than 50 years of durability. Now, this was submitted at the time by DuPont, and it was more related to neoprenes and things like that, but their prediction is 50 years and out. Nobody can go beyond that at this point. And it's already built into your subfloor adhesive and we conform to that too. So.
Thanks.
Part of the reason that the adhesives stopped being part of this solution is because, like Phil said, the inspectors could count nails, but they couldn't see necessarily a bond line. Phil has brilliantly included a UV sensitive filler to the adhesive. So at the squeeze out, an inspector can easily see with a black light that it's indeed part of the structure.
Great. And on the note of durability, of course, the trade-off is always reusability, recyclability of homes and buildings that have this bond. And so if someone is doing a deconstruction of a building, moving a wall, or rebuilding after a disaster that, let's just say, was so bad it ended up doing damage anyway, and the walls were still damaged, how is it, if at all, does a technology like this make that difficult? And one of the specific questions that somebody asked in kind of related to this was, is there a adhesive remover to relax the bond for a demo?
Well, the short answer is no. However, if you have damage to the building where the dimension lumber is damaged and the sheathing, of course, is also damaged, in the case of a bonded system, the dimension lumber isn't going to separate from the sheathing. So you'll have nice clean surfaces that you can surgically cut and reconfigure so you can repair the building, as opposed to 2x4s flying across the street and things like that. That's one of the things you see in many wind and hurricane situations is disconnected lumber from any sheathing laying all over the neighborhood. In our case, that's not going to happen.
What about increasing the resiliency of our existing housing stock? We have millions and millions of existing homes we need to repair and improve. Can this technology help with existing housing? Would it just be limited to additions? How would that work?
We're working on methodologies for retrofitting existing houses. However, those tend to be limited to the rafters and the connection between the roof sheathing and the rafters. You can put an adhesive in on both sides of the rafter. In some cases, you can put a piece of a quarter round molding in and enhance the bond even further. But you get into the walls and you have to tear out the drywall and everything to get at those interfaces. Very, very different. But however, you can get to the bird mouth in some cases and put blocks in and bond them and substantially improve the connections at the bird mouth, which is the rafter to the vertical wall. And if the roof doesn't fly off, you have a greater survivability of the entire building.
Mm-hmm. Well, I'm glad you brought up the bird mouth, because there was a specific question here, probably more related to new construction, but just the difference of why you would use this versus the code required metal hurricane strap method.
We wouldn't. You can use the code required hurricane strap, and in Florida, it's probably extensively required. So the adhesive just adds close to 700 or 800 pounds to the structural integrity of that connection. Nails, as I mentioned, give you about 250 pounds. A hurricane strap adds another 100 pounds to that. And the adhesive brings you all the way up to 1,200 pounds. And at that point, it's pretty hard to rip that connection apart by violent winds and even seismic situations.
Right. So in any case, we're not going against any code or violating code. We're only greatly augmenting what is already potentially demanded. But we are looking into also being included in code, which is a lengthy process. But we definitely are we're definitely exploring means of doing so.
If you have a vital building like a barracks for the military, you can put hurricane straps in, adhesive straps in, and the conventional code, and get a very, very durable, survivable building especially when you have many people living in it. So.
So yeah, there were a lot of concerns and questions, a lot of skepticism from the audience about whether this could be approved for their code, especially in areas with these high wind and seismic risks in lieu of other methods. Sounds like you're out maybe trying to get it adopted, educating code officials. There was one specific question about, do the plywall shear wall capacity calculations for use, are those available? Because they're saying the code officials need those calculations to be acceptable.
Sure.
Yeah.
They are available and they're embodied in several American Society of Civil Engineering papers that were generated by the Western Michigan University Bronco Research Program. The ones on shear walls have data showing performance with nails and performance with nails and adhesives, and those can be included in calculations for code. However, if your code is based on nails alone, we don't do anything to diminish the performance. In fact, we'll enhance it by 200 or 300%. So you're not taking a step backward with adhesives, you're taking steps forward. And those are not required by code.
Right. So the piece where we would be looking to change code is where we would, where people are interested in a substitution scenario.
I have to add that there is a code for subflooring. And for first and second floor subflooring, clearly that's covered by the Uniform Building Code.
Some specific questions here on just the approach is, does it make sense to glue the sill plate to the deck with this technology and the deck to the joist?
Yes. It is a part of an ongoing research program we have at Western. The video showed the rupturing of a Douglas fir sill plate when we hit 14,000 pounds. We're contemplating bonding a sill plate down, but also making an oak sill plate, a white oak sill plate that'll give you much more strength. And of course, a glue line, like 2 beads of adhesives plus the bolts that were in that testing program, will certainly multiply the holding power at that point and help you dissipate energy into the foundation, be it cement or cement blocks. And the white oak is beneficial. We'll get the testing into the documents for the American Society of Civil Engineering in the not too distant future, but white oak is not regarded as a nutrient for termites. They hate it. And so you don't have to worry about using treated wood on the sill plate either. And so if you take something that's a piece of treated wood versus white oak, they're probably going to be cost equivalent in terms of the installation itself. So,
well, you mentioned cost, so I guess let's get to that question. We're thinking about a traditional newly constructed home. Inflation, as of this recording, and hopefully the future when someone watches this isn't the case, but it's off the charts. Construction home costs have never been higher. And we're always asking people to improve the sustainability of their homes, which is going to increase upfront costs. A lot of times those are energy savings, so you can get that payback. Of course, we know the intangible value of a home not being knocked down and somebody's life being saved. But how do you justify, and if there's an increased cost here, what is it? And having those conversations about, what it might be, and how does that differentiate between material and labor? Like, is it just a materiality cost? Is there extra labor here and training needed to do this? Like, can you speak a little bit to just that increased cost?
Sure. I can be happy to share that with you.
Yeah.
Subflooring itself has been well established for 40 years now. The amount of time it took to put the beads of adhesive down and then having nailing every 2 foot on center actually reduced the labor of that particular system tremendously. And not only that, reduce the amount of nails and everything else. But going to the walls and rafters and things like that, there's a minimal cost in putting a 1/4-inch bead of adhesives on any of the studs. And then you're going to make your assembly with nails anyway. And the nails will fixture everything together until the adhesive sets. So I would say that that labor increases couldn't amount to more than 5 or 10%, you know, of the whole framing structure. Having said that, we did a model of a 2,000 square foot house and calculated both the subfloor, the walls, the bird mouths, and the rafters are required to do it according to code. And the cost of the adhesive at $13 a sausage calculated out to about $4,200 for the entire house. Now, with other people giving us input on the cost of materials in general, we got a number of $170,000 in material costs, not labor, for a 2,000 square foot house. With $4,200, we're only adding 1.5% to the material cost of the entire house and increasing the structural integrity by 200 or 300%. It doesn't cost that much to go first class. You have more security, and the homeowner shouldn't, you know, suffer from this kind of improvement. So.
Yeah.
Well, because we're also aiming to get this accessible globally for, you know, least developed countries and that kind of thing. And there's so many, you know, communities domestically that are hardest hit by climate change that also don't necessarily have a lot to, you know, put into their structures. So we're very, very mindful of accessibility and price point, and that's for anybody. We want everybody to be able to, you know, reinforce their structures.
Yeah.
I like seat belts. A seat belt will improve the survivability of an automobile.
Yeah.
But who wants to put it into the cost of the car? That went on for 10 years, you know.
Sure. Well, and, you know, and I think about, somebody brought up a question here, but to expand on it a little bit, you know, we know that insurance, you know, home insurance agencies are increasing cost, if not now flat out rejecting homes in certain areas for certain reasons, much to do with climate change. So somebody brought up, you know, their kind of specific question was, you know, if you were aware of the fortified home standard and if they have these types of adhesives, or if they should be made aware of this. But I know that fortified home standard was an intent upon the insurance agencies to say, hey, if you have this standard in place, perhaps maybe you get a lower insurance rate, or at this point, from what I'm hearing, maybe we can even insure you or not at all these days. So do you see something like this being part of that conversation with maybe the cost savings come from
the insurance research program, IBHS, and their whole idea of a fortified home was taking hurricane straps and hold downs and gang nails and use it throughout the structure. And they have a wind facility, and they demonstrated a certain amount of survivability, at least to the satisfaction of the insurance industry. We talked to them about the possibility of using adhesives with the fortification that they had. And they said, well, we already have all this testing. And so we're still trying to get them to accept the fact that we can enhance tremendous amounts of durability into the building itself. It's going to take some time.
Yeah.
And we're not trying to change codes. We're just trying to enhance the existing codes.
Sure.
Believe me, trying to change codes is going to be 20 years.
Right. Yeah.
We don't have 20 years. We don't have 20 days.
Right. Yeah.
And Florida may not even have 6 months.
Yeah. Yeah.
So,
well, it's certainly a large undertaking, and you know, it's great that you all are doing that work. Before we wrap up, there was one last question just on the installation side that I think is important that I wanted to get to, and that was the moisture content of the surfaces being adhered. You know, does that have any effect on the bond at all?
obviously you don't want to have standing water.
Yep.
Moisture is a benefit when you're looking at a moisture curing adhesive. So if the moisture content of wood normally is 13%, and let's say because it's been out in the rain a little bit or something like that, it jumped to 15, 16%. That moisture is imbibed into the glue line and it's part of the reaction that drives the polymerization of it. So it's beneficial. Now, on the other hand, the situation you'd get in Arizona where your moisture content of the wood might be 7 or 8%, there's still enough moisture in the wood to feed the reaction and complete the polymerization reaction. So we find no setback from dry wood or damp wood. Now, soaking wet wood is another issue. So
Makes sense.
thank you so much.
Thanks, Brett. So if anybody wants to get in touch with us, please do so about any engineering questions, any partnering opportunities that you can think of. We're happy to help with any project specifics. So please, all the technical data sheets as well as videos are on our website, www.climateadhesive.com. And my and Phil's emails are displayed here as well.
All right. Well, Kristin, Phil, Climate Adhesive, thank you so much for your time.
Great.
And take care, everyone else. Thank you for joining us. Goodbye.
We'll be in touch. Thanks so much. Take care.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.